Hi, this is lesson 3.2, and in this lesson we're going to use properties of parallel lines to find angle measures. Now, in the last lesson we learned about corresponding angles, so we're going to talk about those for a little bit. Angle 2 corresponds to angle 6, right? Because they're both above the line and to the right of the transversal. Now watch what happens. I need to change this. Look at the size of angle 2. If I move that down, look, angle 2 and 6 are corresponding and they are the exact same size. Now let's look at angle 8. That corresponds to angle 4, and sure enough, those are the exact same size. But notice, these lines are parallel. If those lines are crooked, or if they were not parallel, like if this went way down here, well then angle 4 and 8 would not be the same. Angle 5 corresponds to angle 1, and those are the same size. And angle 3 corresponds to angle 7, and those are the same size. So that brings us to the corresponding angle postulate. It says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So we have parallel lines. When they're cut by a transversal, angle 2 and angle 6, okay, those are the two that we have, those would be congruent. Also, this angle would be congruent to this one. This angle would be congruent to this one. And this angle would be congruent to this one. So all the corresponding angles pairs are congruent. So using that, it says the measure of 3 of the numbered angles is 120. Identify the angles. All right, so this angle is 120. So the angle that corresponds would be this angle. So this would be 120. Now, we also know that angle 4 is 120 because what are these angles? They're vertical. So this is also congruent. And these two are vertical, so this is also 120. It's kind of cool because we are able to answer all of these angles here. We know that angles 6 and 8 are a linear pair. So 180 minus 120, you know, that's 60. And this is 60. So this would be 60. And this would be 60. So we were able to fill in all of those angles just by having one. All right, alternate interior angles theorem. That says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. And this is a fun little proof. Now, this is a theorem. And remember, theorems have to be proven. They're like theories. You have to prove them. So the proof is fairly short. You start out with parallel lines cut by a transversal, so that's given. And let's see, we're trying to prove that angle 1 and angle 2 are congruent. That's what our goal is. We're trying to show that if you have the situation that the alternate interior angles are congruent. That's our goal. That should be the last statement. Well, you know that angle 1 and angle 3 are congruent. Why? Because of the corresponding angles are congruent. The postulate, okay? So angle 1 and angle 3, those are congruent. Well, we also know that angle 3 is congruent to angle 2. Why? Because angle 3 and 2 are vertical angles. So vertical angles are congruent. So if 1 is congruent to 3 and 3 is congruent to 2, all right, so 1 is congruent to 3 and 3 is congruent to 2. Well, what do we know about 1 and 2 then? Then 1 and 2 are congruent by what? What theorem was that? Transitive property. So remember, those theorems are on the second page of your proof sheet, so keep that handy. All right, alternate exterior angle theorem says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So we also know alternate exterior angle 1 and angle 8 are congruent, and angle 7 and angle 2 are congruent. So that's the alternate exterior theorem. And again, that has to be proven, and that is done in your textbook, so we're not going to take time to do it today. All right, mark the alternate interior angles. So the alternate interior angles are angle 3 and angle 6. Now, one way, like if you're looking at this and you can't remember, should these be congruent or not, these are both acute. So this is one of those times you can a little bit go by looks. So they're acute, where these two are both obtuse. So these two are congruent and these two are congruent. Angle 3 and angle 6, angle 3 and angle 6, and angle 4 and angle 5. And I should just say they're congruent. I can use those symbols because of those theorems. Same side interior angles. Now this one is different. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay, so in this case, angle 3 and angle 5 add up to 180. Now here's how the proof basically goes with this. Let's see, this angle and this angle are congruent, right? Because they're called corresponding angles. Well, if this is whatever angle 5 is, this one is the same size, okay? These are the same. So what do you know about this angle and this angle? Right here, here, and here? Well, they're a linear pair. And so they add up to 180. So then angle 3 and 5 add up to 180. Another thing, if you look at angle 3 and 5, angle 5 is obtuse, angle 3 is acute. So there's no way they could be equal. So that's another clue for you to remember, oh yeah, those are the two that are supplementary. All right, let's do some problems. Now there are different ways you can do these problems, which is kind of fun. You could start out here and you could say, oh, angle 60 and angle 2, these are same side interior, so they're supplementary. So that would be 120, because 180 minus 60 is 120. Or cover that up and look at these two. These are alternate interior. They are congruent. So they're both 60. Or once you say that this is 120, you know these are a linear pair. So 180 minus 120 is 60. Here, these 120 and this one, these are alternate exterior. So those are both 120. Or if you cover that up right there, don't look at that, angle 120 and angle 2 are corresponding. They're both 120. And also angle 1 and angle 2 are vertical, so you would know their size from that. All right, here we have angle 80 and angle 1, or this 80-degree angle, and this is angle 1, so these two are supplementary, which means that this has to be 100, and these are alternate interior, so that has to be 100. All right, here we have 95, which means this is 95. And then this would be 180 minus 95, which is 85, right? 95, 85, just going to double check myself. Yep, there we go. All right, and in this one, this is 106, which means this is 106 because they are corresponding. And a couple ways you could do that. You know that these two have to be 180. So this would be 74, so just subtract. All right, and over here, if this is 90 because they're corresponding, and these two have to be a linear pair, which makes that 90. All right, because the measure of angle 1 is 105, find the measure of angle 4, 5, and 8, and tell which postulate or theorem you would use. So angle 4, well, that would be 105 because they're vertical angles. Angle 5, okay, you could do it a couple ways. You could say that angle 1 and angle 5 are corresponding, or you could say angle 4 and angle 5 are alternate interior. Angle 8 and angle 4 are alternate exterior, or you could say angle 4 and angle 8 are corresponding, or angle 5 and 8 are vertical. So all of those are congruent. Alrighty, next, find the value of x. So now these get a little bit more complex. Now if you look at this angle right here and this angle right here, one is on the interior, one is on the exterior, so they're not a special angle pair. So we have to play around a little bit. We have different ways we could do it. You know that if this angle is 115 right here, that this angle is 115. So you could say that this one plus this one equals 180. 115 plus x plus 5 equals 180. That's one way to do it. Or if this is 115, this is 115, and you know that this one and this one are same side interior and they are supplementary. So again, you would add those together and set those equal to 180. So now we have 120 plus x equals 180. So x equals 60. All right, let's do another one. Now this one has a lot of lines. Sometimes, okay, this is my helpful hit. Whenever you do problems like this, when there are parallel lines, like highlight those lines. Get out a highlighter or extend the lines. Sometimes it's just easier to figure out what you're really looking at. Okay, so those are the parallel lines. There are extra lines here. This is the transversal right here. Well, that's one of the transversals. Let's see. That's not the one we need. I'm going to go back here. This one, look at this one right here. What do you know about this angle and this angle? These two angles are same side interior, which means this one plus this whole angle have to add up to 180. So 80 plus, okay, this would be 40 plus y. All right, that angle there, that whole thing would be, this is the angle addition postulate, 40 plus y plus 80 equals 180. So that would be 120 plus y equals 180. So y would equal 60. All right, next one. What are the measures of angle 3 and angle 4? Hey, let's see here. Angle 3 is right here. So angle 3 and angle 105 are alternate interior. Again, we've got a lot going on here. So just so we don't have to look at the other ones, can I even cover those up? These are alternate interiors, that's 105. All right, now angle 4 and 5, that's using this one, not angle 4 and 5. Angle 4 and this 105. Okay, it's using these two lines. These two are same side interior, so they add up to 180, so that would be 75. All right, and now you're going to do a worksheet. This is lesson 3.2. So the first ones are like what we've been doing. Let's take a look at the next page here. We're going to cross out this one. This one's just a little bit hard to see. Now, number 7, this one is different than what you've seen, but again, you have parallel lines, and remember my helpful hint. Extend the lines, okay? And then these are the angles that we have information, so extend that. All right, so now we see, what do we have? We have same side interior, which means this angle plus this angle. So that's what the second angle is. It's x minus 26 equals 180. And then you can solve that. All right, let's look at this next one here. Now this one, we have this angle and this. So this is interior, that's exterior. And this is these are both x's, and that's a y. So let's do this. We know that this angle and this one are vertical angles. So this angle right here is 3x plus 23, and this angle right here is 2x plus 12. These are same side interior. So you could do 2x plus 12 plus 3x plus 23 equals 180. And then you solve that equation. And then you're going to have to plug x back in to find this angle. And then whatever this entire angle is, you have to subtract from 180 to find y. So that's a hint to get you started. Again, extend these lines. And then this is the transversal, which means you've got this angle, and those are corresponding angles. All right, I want you to work on those. If you get stuck, just circle the questions and let me know when we meet again together. Thanks for watching.